This is the video lecture for Math 110 for Monday, April 20th, Part 1. And the topic for today is right triangles and trigonometric functions. So we're getting into an entirely new area now. We're leaving behind sequences and series and simple and compound interest. And we're getting into the last segment of the course, which is basically some simple trigonometry. First, let's talk about what an angle is. Basically, an angle is the opening between two lines. That's defined as an angle. And we have two lines here, and typically we could label an angle with a little line connecting, a curvy line connecting these two lines. And typically we use this symbol here, which is called theta, but it's usually used for an angle. So this symbol is a Greek letter, it's called theta. It's used to represent angles, but we can represent angles with other things. And basically there's two ways to measure angles. You can either measure angles in degrees, and there's 360 degrees in a full circle. Or you can measure angles in what's called radians, and there's 2 pi radians in a full circle. In this class, we're pretty much going to use degrees, but it's good to know you can also use radians. What I want to talk about now is a right triangle. Hopefully you guys all know what a triangle is. A triangle is basically, it's a 3-sided object, and it sits in a plane. A right triangle is a triangle in which one of your angles is 90 degrees. So this would be a right triangle. Okay, it's a triangle in which one of your angles is 90 degrees, and the way we indicate that is we indicate this with this kind of like square symbol here. So this angle is 90 degrees, and we can label these different sides A, B, and C. Now, right triangles are a special type of triangle, and when you have a right triangle, there's a theorem that relates the lengths of the sides of a right triangle, and I'm sure you guys have heard of that. It's called the Pythagorean Theorem. And the Pythagorean Theorem basically says, this long side of a right triangle is called the hypotenuse. So the Pythagorean Theorem says that if you square the hypotenuse, okay, the square of the hypotenuse is equal to the sum of the squares of the other two sides. So c squared equals a squared plus b squared. If you were to solve this for c by taking the square root of both sides, you could do that, and that would give you c equals the square root of a squared plus b squared. So this is called the Pythagorean Theorem, and it's a handy relationship between the sides of a right triangle. Let me do an example problem with the Pythagorean Theorem. So suppose we had a right triangle that had the following lengths. And let's suppose that this side was equal to 6, and this side was equal to 10. This is a right triangle, and this is our side C. Okay, we want to figure out what the length of the hypotenuse is. We can use the Pythagorean Theorem, so C would equal the square root of the sum of the squares of the other two sides. So C will equal 6 squared plus 10 squared. Okay, and that equals the square root of 36 plus 100. Which equals the square root of 136. And this equals, if you plug this in your calculator, you get 11.66. So C is equal to 11.66. So this is a method we can use to figure out the length of the hypotenuse. Now I should mention, we also can have a situation where we know the length of the hypotenuse, and we know one of the other sides, and we have to find the other side. The other shorter side. We can still use the Pythagorean Theorem for that, but in that case we would know C, but one of the sides here we wouldn't know. So you have to do a little bit of algebra to figure out that side. So that's also a legitimate problem. So this is the Pythagorean Theorem. What I want to do is I want to consider, let me erase this now because that basically concludes the Pythagorean Theorem. What I want to do now is talk about trigonometric functions. So I'm going to introduce you guys to some trigonometric functions. I'm sure you've seen these somewhere in your high school career. Okay, and what I'm going to do is draw a right triangle as such. Okay, I'm going to keep this general with C, A, and B. And I'm going to label, this is our right angle. I'm going to label this angle, this is not a right angle, I'm going to label it theta. And then I'm going to, we're going to talk about, there basically are, there are 6 fundamental trig functions, but in this class we're only going to talk about the 3 most important. So it turns out one of those functions is the sine. And the sine of your angle theta, the sine of an angle is defined on a right triangle. And it's defined as the opposite side divided by the hypotenuse. The length of the opposite side divided by the length of the hypotenuse. So in this case, and for this triangle with the labeling we have, the sine would be b divided by c. That's called the sine. That's one of the trig functions. Then you can have the cosine of an angle. The cosine is equal to the length of the adjacent side divided by the hypotenuse. And for this triangle, that would be equal to A is the adjacent side divided by C. And finally, we have the tangent function. Tangent of theta is defined as the length of the opposite side divided by the length of the adjacent side. Okay, and for this triangle, that would be B over A. So these are the definitions of the 3 most important trig functions. And what I want to do now is an example problem using these trig functions. So let's draw our triangle over here. We'll take a specific example. Actually, let's go back to the example we considered earlier. We had a right triangle here. Okay, this angle was right. This side length was 6. This side length was 10. And we found that this side length was 11.66. There's 2 parts to this example problem. So the first thing I want to do is I want to find, and this is our angle theta. This is the angle I'm interested in. I want to find the sine of theta, cosine theta, and tan theta for this triangle. The values of sine theta, cosine theta, and tan theta for this triangle. I'm going to use these definitions here. So our sine of theta will equal the opposite over the hypotenuse. Equals 6 is the length of the opposite side. Over 11.66 is the length of the hypotenuse. If you guys plug this in your calculator, this comes out to 0.515. Okay? And then I also want to find the other trig functions. So cosine of theta, cosine of that angle is equal to the adjacent divided by the hypotenuse. That'll be 10 divided by 11.66. And this comes out to 0.858. Okay, that's the value of the cosine of that angle. And then finally, I can find the tangent of this angle. Tangent is equal to the opposite over the adjacent side. And so the tangent comes out to 6 over 10. Okay, and that's exactly 0.60. So now I've found the sine, theta, tangent, cosine, and tangent of this angle. Okay. And now what I'm going to do is I'm going to, there's a second part to this problem, and actually I don't want to erase the bottom, so I'm going to erase the top here. And we're going to do the second part above the first part. Okay, part B of this problem is I want to find the angle theta in degrees. What is my angle theta in degrees? Okay, because I now know the sine, cosine, and tangent of the angle, but I don't know the angle itself. What is this angle? How many degrees is it? And there's a couple ways I can do this. I can actually use the sine here. I know, what do I know? I know sine of theta equals 0.515, okay? But how do I actually figure out the angle? And the way we do this is we use something called the inverse sine, or the arc sine. So what I do is I take the inverse sine of both sides of this equation. And that's legal. I can do anything I want to one side as long as I do the same thing to the other. So I'm going to take the inverse sine inverse of the sine of theta, and doing this to the other side, this equals sine inverse of 0.515. Now, this is an inverse function of sine, and I'll just tell you guys this, we haven't really talked about this, but basically inverse functions undo the functions themselves. So if you dug a hole, the inverse operation of that would be filling it back in. It negates what you did earlier. Inverse sine negates the sine. Whenever you have inverse sine of sine, this leaves you with simply theta. So this sine and this inverse sine and sine kind of undo each other, and they just leave you with the angle. So here we get theta equals the inverse sine of 0.515. Okay, now what you do is you plug this in your calculator, and your calculator should have a button on it. Your calculator, by the way, has sine, cosine, and tangent buttons. So you can calculate the sine, cosine, and tangent of any angle. One word of note, caution, that your calculator can be in both degree mode and radian mode. You guys want to be in degree mode. Make sure your calculator is in degree mode. If it's in radian mode, it'll give you the wrong answers and you won't get the credit you deserve on the test. So make sure you guys are in degree mode. And then if you want to, you also can find the inverse sine, cosine, or tangent of things. The way you do that is, like my calculator, I have the sine buttons, and then above that, there's the inverse sine. So I would hit second. I would hit the second button, and then I would hit, plug in my number. So I'm going to plug in 0.515. I'm going to hit second, and that indicates inverse sine. And this angle comes out to 31.0 degrees. Okay? So this angle is actually 31.0 degrees. Now, there's another way to find this angle. We could have used any of these other two functions to find this angle as well. I'll use tangent. We also know tangent of theta equals 0.6. So what I could do is take the inverse tangent of both sides of this equation. Inverse tangent of theta. Okay. Again, inverse undoes the action of tangent, and so I just get theta. And then the other side, I get inverse tangent of 0.60. Now, if I plug in this into my calculator, let me do that. Inverse tangent of 0.6. So at 0.6 second inverse tangent, I get 31.0 degrees. Okay? Which is the same thing, and that makes sense because this angle is the same angle. The angle doesn't change. So whether you use sine, cosine, or tangent, you can use any one of those functions, and you can figure out what our angle is. So make sure you guys know how to do a problem with a right triangle. We have a right triangle. We know 2 out of the 3 side lengths of the triangle. We can use the Pythagorean Theorem to figure out the third side length, whether it be the hypotenuse or one of the other sides. And then we can also be able to write the values of sine, cosine, and tangent of this angle in a right triangle. And then also finally be able to actually figure out that angle by taking the inverse sine, inverse cosine, or inverse tangent. Okay, that concludes part 1 of this video lecture.